Okay, hello everyone. I'm going to go through some revision with you to help you put all the bits and pieces of linear equations together. So let's get started. Now here are some of the main things you need to be able to do for the test on Friday. Now what I've done, I've made a list here of things we need to look at, and on the next slide you will see I've set a couple of questions, not very many, just one or two or three questions for each little dot point so that you can practice what you've learned, okay? So they're the questions I'd like you to have a go at in preparation for Friday. And as a matter of fact, I will give you Thursday's lesson to work on those. Okay, let's get started then. The first point we need to be able to do is plot a point on a Cartesian axis. So what does that mean? Let's have a look. So the first point, we need to be able to, if here's our set of axes, we need to remember that the vertical axis is the y-axis and the horizontal axis is the x-axis. And the numbers along here are, let's put them in, 1, 2, 3, 4, 5, 6, and so on. And our y values here are 1, 2, 3, 4, 5, and 6. Now, this is our x-axis. These are our positive values. Over here we've got negative values. So it'll be negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. And likewise with the y-axis, we've got negative y values down here, negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6. Now, of course, those values keep going. But just to give you an idea, let's say we want to plot the point 2, 4. Now, you have to remember that the first number is always the x value, and the second number is always the y value. So x first, then the y value. So the point 2, 4, we would find the x value first. We're looking along the x-axis, and we're looking for 2. There it is there. Actually, I'll probably do that in the right colour, I think. So there's our value, our x value, 2. And looking at our y value is 4, so look up and down the y-axis for the 4. There it is there. So the point 2, 4 will be where these two points come together. So it'll be somewhere along there and somewhere along there. So the point actually is there. That's where the point 2, 4 is. I'll do one more example. Let's say we had the point negative 4, 5. Well, remember, the x value is first, so that's our x value, and there's our y value. So the x value is going to be negative 4. So that's negative 4 there, by the way. So there's our x value, and our y value is 5, so it'll be up here. There's our y value. So the point negative 4, 5 will be about there. And that's all there is to it. Just remember, the first number is the x value and the second number is the y value. Okay, let's go on to the next point. Generate a table of values given a linear equation rule. Okay, so Let's have a look at that. So let's say we had an equation, a rule like this. Say our rule might be something like y equals 3x minus 5. Now we need to generate a table of values. Now a table of values, you might remember, is a table like this where the left-hand side are the x values and the right-hand side are the y values. And normally the x values are given to you. So I'm going to put some x values in there. We'll make them -4, -2, make the next one -1, then 5, and then 11. So let's now work out the corresponding y values. So what you need to be able to do is take each of these x values one by one, substitute the x value into where we see the x value in our rule, and then work out the corresponding y value, and then that y value we place on the other side of the table. So let's do a couple. So let's try -4. So when x is -4, let's work out the corresponding y value. So it'll be y equals 3x. So we write the rule down first, 3x minus 5. Now 3x means 3 times x. So it's going to be 3 times, now I'm going to use brackets. Brackets, these two things are being times. Now x has a value of -4. So it's going to be 3 times -4, then -5 on the end. Don't forget the -5. So that will be 3 times -4, which is -12, minus 5, and that equals -17. So the value that goes here is -17. Let's try x equals -2. So now we'll try x equals -2. So we'll plug that into our equation. So write down the equation first. Y equals 3x minus 5. That's our rule, our linear rule. Now where we see the x, we're plugging in or substituting the number -2. So it will be y equals 3. We'll put them in brackets, 3 times -2, then -5 on the end. 3 times -2 is -6, and -5 is -11. So the value there is -11. Let's do 2 more together. We'll do -1. So we'll plug that number in. So for x equals -1, write our equation down first. Y equals 3x minus 5. This time x equals -1. So we replace or substitute the x value for -1. Remember, 3x is 3 times x. That's 3 times -1 minus 5 on the end. So 3 times -1 is -3. Minus 5, and that equals -8. And the last one we'll go ahead and just jump to 11, I think. So we'll do the 11 this time. And so x equals 11. So we write down our equation first. Y equals 3x minus 5. So that will equal 3 times 11 minus 5. 3 times 11 is 33. Take away 5 is 28. So the answer there is 28. Now that we've got our table of values, each of these sets of points represents a coordinate that we can plot on a graph. So for example, and we'll change colour again, we'll go back to white. So that point there, this is the x value and this is the y value goes with it. So that actually corresponds to the point -4, -17. This one corresponds to -2, -11. And this one corresponds to -1, -8. And this one corresponds to 11, 28. Now, we can plot those points on, well, for example, on Desmos, or you could just graph them on a plot. I'm going to do it on Desmos just to make it a little bit quicker. So the first point is -4, -17. -4, -17. The second point is -2, -11. I might zoom out a bit to see the points. The third point is -1, -8. And the last point we got was 11, 28. Now you'll notice that all of those points fit on a straight line. So here are the points. I'll just highlight them for us. Those 4 points sit on a straight line. Now, to prove that these points all sit on the line described by this equation, I'm going to type that equation in. Now remember, this is a linear equation. Remember, the number in front of the x is the gradient, which we call m. So remember, it's y equals mx plus c. The number in front of the x is the gradient, which is the slope of the graph, and the number on the end is called the y-intercept. So there's our gradient of 3, and there's our y-intercept of -5. So let's type in this equation to Desmos and see what it does. Y equals 3x minus 5. Well, look at that. It goes through each of those points. Each of those points. And so that confirms that each of these points sits on the line, or obeys the rule, y equals 3x minus 5. And each of these points, if I move along here, each of those points is a point on this line. So for example, when x equals 10, y equals 25. When x equals 10, y equals 25. Let's see if that's true. So we think when x equals 10, y should equal 25. Let's try it. So we'll go x equals 10. Let's plug it into our rule. Y equals, it's 3x minus 5. This time, x is equal to 10. So it'll be 3 times 10 minus 5, which is 30, minus 5, which is 25. How about that? So when x equals 10, y equals 25, which is exactly the point that we thought. So if I plugged in the number 5.82 into our rule, we should expect an answer for y of 12.46. If I plugged in the number If I plugged in negative 10 into our rule, we should get a y value of negative 35. And so you can experiment and confirm those results. Okay, so that's what we mean by generating a table of values and being able to plot it to create a straight line. Okay, the next point, determine the rule from a table of values. Well, an example of that might be this. Let's say we've got a table of values that looks like this. Negative 4, negative 2, 0, 2, 4, 6. Okay, now I've got a rule in my head. I've got a rule, but you don't know what it is. I do, but you don't. So I'm going to take each of these x values, plug it into my hidden rule, and I'm going to tell you what the y value is. So the first one will be negative 4. The second one will be 0. Third one will be 4. Next one will be 8, 12, and 16. So I'm doing the same thing to each one of these numbers to get the corresponding y value. Now, you could sit here and try to work out by trial and error what you think it is. Some of you might already know what the rule is. But if we could plot it on a table of values, if we could plot it on a graph, the rule would look very, very obvious. So that's what I'm going to do. I'm going to plot them on a table of values on Desmos. Negative 4, negative 2, 0, 2, 4, 6. So we'll clear all this. So negative 4, negative 2, 0. Negative 4, negative 0, 2, 4, 6, and our numbers were negative 4, 0, 4. Our y value were negative 4, 0, 4, 8, 12, and 16. Okay, so clearly, they form a linear rule. They form a straight line. So let's see if we can work out what the rule is. Now, this will also come back to the idea of understanding how the gradient and the y-intercept affect a straight line. Now, we can hopefully see that I'll zoom in actually, that these points are cutting the y-axis at this value here, which is 4. So it looks like our y-intercept is 4. So y equals, now I don't know what the gradient is, so I'm going to call it m for gradient, but I think that my y-intercept is 4, plus 4. Well, there's the line. Now, if I want to make, it's obviously going through the point 4, that's correct, but the slope is wrong. I need to make the graph steeper. So I need to increase my value for m. Now notice 3 is too far, but when I make m equal to 2, it goes through each of the points. So the rule here is y equals 2 x plus 4. So the hidden rule was y equals 2x plus 4. That was the rule. So one of the things you need to be able to do is to plot points on a graph and use that graph to help you work out what the rule is. Now in a moment we'll go through how to work out the gradient using the points on a graph. And by the way, there's a second video on that anyway, on how to work out the gradient between 2 points. But we'll come back to that in a moment. Okay, so actually we'll talk about that now. So we could see by plotting those points that the y-intercept was 4, but it's not really obvious what the gradient is. By using Desmos, we could see that the gradient was 2, but let me show you how we could do it without Desmos. Now, remember, to find the gradient, all we need is 2 points on the line. Now I'm going to take this point and this point. We'll take, that point is 0, 5. Actually, no, we won't. We'll take those 2 points. We'll take the points 2, 8, which is that point there, and the other point we'll take is 4, 12. So we'll take 2, 8 and 4, 12. By the way, it doesn't matter which point you take. You can take any point you like. Pick any 2 points and you'll get the same result. So let's see if we can work out the gradient. We suspect the gradient will be 2 because that's what our line is telling us. But let's see if we can do it without Desmos. So let's pick our 2 points. There's one point we're going to use, 2, 8, and there's the other point, 4, 12. Okay, so I'll turn those into coordinates. So that's the point 2, 8, and this is the point 4, 12. Now, if you remember last week, we learnt a formula how to work out the gradient given any 2 points, and I'll just go over that formula now. The gradient, to work out the gradient, it equals y2 minus y1 over x2 minus x1. So, all we need is 2 points. Well, here's our 2 points here. I could have picked these 2 points, this one and this one, but I'm choosing these 2 at the moment. So the first step is to call one of the points 1. We'll call that point 1, and we'll call this one point 2. Okay, so let's write those points down again down here. So our point number 1 is the point 2, 8. And our point number 2 is the point 4, 12. Now, remember, this is an x value and this is a y value, but because they are the coordinates of point number 1, we'll call this x1 and we'll call this y1. So that's x1 and that is y1. Over here, this is point number 2. So we'll call this value x2, and here's the y value for point 2, so we'll call that y2. So now we know what x1 is. x1 is 2. We know what y1 is. y1 is 8. We know what x2 is. It's 4. And we know that y2 is 12. So all we need to do is now plug those numbers into our formula, and that will give us our gradient. And hopefully, if we're right, when we do this, we will work out that the gradient is 2. Let's see if we're right. So our gradient is y2 minus y1. Well, where's y2? y2 is there. There's y2, so it's 12. So it's 12 minus y1. y1 is over here, it's the value 8. So it's 12 minus 8 over x2 minus x1. Well, here's x2 here. That's 4. And x1 is 2. So it's 4 minus 2. So let's simplify this. So 12 minus 8 is 4. 4 minus 2 is 2. 4 over 2 is 2. So our gradient equals 2. And that's what we suspected. So you can actually work out the gradient using a table of values, and you don't need to use Desmos. All you need to do is choose 2 points in the table, use this little method to work out the gradient, plot the points on a graph like this, just plot them on a set of axes, and where it crosses the y-axis, that's your y-intercept, and that's all we need to do to find the rule. So we could work out, first we worked out the y-intercept was 4, and then by using this method here, we worked out the gradient was 2, and so we know the rule is y equals 2x plus 4. I might do one more example of this because this is really important. So let's say I've given you a set of axes, a table of values of the following values. We'll make them -3, 0, 4, 9. And I'll put another one in there, 10. Okay, here are the corresponding values. That will be -12, -3, -9, 24, 27. Okay, now we're not going to use Desmos, and we're going to work out what the rule is for this table of values. Now, or we might use Desmos just to plot the points, but you could plot the points on simple graph paper. But we'll work out the gradient first. So let's pick 2 points, and I'm going to pick that point. And it doesn't matter which 2 points. It could be any 2 points you like. I'll pick that point, and just to mix it up, I'll pick that point down here. So they're the 2 points I'm going to pick to work out my gradient. So that point is going to be the point -3, -12. That sits on our line somewhere. And this one will be the point 10, 27. So I'll call this point number 1, and I'll call this point number 2. So let me write down the values again. So point number 1 is -3, -12, and point number 2 is 10, 27. So this is point number 1, this is point number 2. So this will be our x1 value because it's the x value for point number 1. This will be the y value for point number 1. We call that y1. Over here we've got x2 because it belongs to point number 2, and there's y2. So let's write down our formula. We know that m equals y2 minus y1. This is the gradient over x2 minus x1. So let's plug our numbers in. There's y2, and y2 is 27. So it's 27 minus, what's y1? y1 is -12. -12. So it's 27 minus -12. Let's look at the x values. x2 is 10. There's our x2 value. It's 10. So it's x2 minus what's x1? x1 is -3. So it'll be 10 minus negative 3. So if we now work this out, remember, if you get a minus minus, that changes to a plus positive. So that becomes plus positive. Likewise on the bottom, that will become plus positive. So on the top, 27 plus 12 is 39. And on the bottom, 10 plus 3 is 13. 39 divided by 13 is equal to 3. So guess what? The gradient of this line is equal to 3. Now, let's see if we can work out the y-intercept. So we know the gradient, so it's going to be y equals 3x, because the gradient is 3, so it's y equals 3x plus something. We don't know what the something is. This y-intercept, let's see if we can work that out. So let's plot our points. Now what I'm going to do, you would do this, if you didn't have access to Desmos, what you would do, you would simply plot these points on graph paper. But I can't do that with you at the moment, so I have to show you how to do it on computerized graph paper, which is Desmos. So we're going to put the points -3, 0, 4, 9, 10. So we will get rid of that. So it's -3, 0, 4, 9, 10, and we don't need that last value. And the -3, 0, 4, 9, 10 on the right hand side, or the y values are -12, -3, 9, -12, -3, 9, 24, 27. 24, 27. And we don't need this one. So let's zoom out and see what our points look like. Whoops. Well, look at that. Once again, they're in a straight line. So let's see if we can find the rule. Now, from our this calculation, we think the gradient is 3. We worked out the gradient. So let's try that. Let's try m equals 3. And I'll actually turn the line on. So y equals 3. Sorry, m equals 3, I beg your pardon. Now, look at the slope. That's the right slope. It just needs to come down a bit, doesn't it? So we need to bring our graph down. So that point there, that's cutting at 4. But look at this. It's actually cutting down here at this value. Let's reduce it. So it looks like it's cutting at a minus value. Let's try -2. Oh, not quite. Let's try -3. Well, what do you know? That's done it. So we can now see that the graph is y, or the rule is y equals 3x minus 3. And there it is. And all we needed to do, the hardest part was working out the gradient from our table of values. Okay, so that takes care of all this. Remember the gradient, to work out the gradient between any 2 points, it's the rise over the run, or otherwise it's y2 minus y1 over x2 minus x1. So that, what we've just been talking about, covers this section here, all of this, and our general formula for a straight line. Just a couple of final points. This material at the bottom is very closely related to what you've been doing on Desmos, and just a couple of quick things we'll talk about. If you've got a pay offer, say you're earning $40 per hour, plus you have a baseline payment of $250 per week. So that's your payment or your wage per week, your weekly earnings. We can represent this as a linear equation. Now, our weekly earnings, normally in this sort of arrangement, we're going to call the weekly earnings Y. So Y is the weekly earnings. Now we're earning $40 per hour. So if I worked for 1 hour, I'd earn $40 plus $250. If I worked for 2 hours, I'd be earning $80 plus $250. 3 hours, it'd be $120 times $250. So I'm multiplying the 40 by the number of hours I work. So it's going to be 40 times the number of hours. Well, the letter I'm going to use for the number of hours is the letter X. And then the amount on the end, the amount we get paid regardless of how many hours we work, is that. So there is an equation for this particular pay arrangement. Now what I want you to make sure you know, make sure you realise that the hourly rate, look at that, the hourly rate, which is here, is the gradient of the graph. So the gradient of our linear equation is the hourly rate. The amount we earn regardless, in other words, the amount they pay us up front before we've actually worked any hours, this value here, that is the y-intercept. And that is our base amount, if you like. And so if we had two pay arrangements, for example, if I had another one over here, and I'll write it in a different colour, we'll go with green. Let's say we had another pay offer from another company, and it was y equaled 35x plus 320, then we could see that our hourly rate, the hourly rate in this particular example would be $35 per hour. So here the gradient will be $35 per hour, and the base amount they're going to pay us is 320. That's our y-intercept. So there's our y-intercept, which is our base amount. Now let's sketch both of these on a graph. So we'll do this one first. Y equals 40x plus 250. And we'll now do the second one. Y equals 35x plus 320. Now, in order to see what's going on here, we need to zoom out. So that's exactly what I'm going to do. And the other thing I need to do, look at our scale, look at our X scale. This is the number of hours we're working. I don't think we'll be working 500 or 1,000 or 1,500 hours a week. So we need to do something about that scale. So I'm going to just change that for a second. So I'm going to change my scale from, we'll make it from -5 to, I think, 50 hours in a week is probably more than enough. Now that's looking a bit better. Okay, so we'll go with that. And we'll probably now zoom in a bit now. Zoom in. Okay, so look at this. The purple equation So the green equation was our first one. Now notice, if we don't earn any money at all, we're going to earn $250. So 0 is the number of hours we're working, and that's the X value. The Y value is the 250, which is how much money we've earned. So if we work 2 hours per week, that means we're going to earn 2 times 40, which is 80, plus 250, which gives a total of 330. That's how much we're going to earn if we work 4 hours in the week. It'll be $410. So as you work more hours, your pay goes up. So look at this. At a certain point, at that point there, at 14 hours, we're earning $810. Now we keep going. There's 18 hours, $970. Okay. Let's look at our purple line. Notice the purple one, we start off earning more money. So even if I don't work anything at all, no hours in that week, I get $320. And now that's what I earn if I work for 2 hours. I earn $460 if I work for 4 hours. I earn $530 if I work for 6. Now look at this. As I keep going, the amount goes up. But look at this. At a certain point, look at that. When I have 14 hours, I earn exactly the same amount as if I was working on the other job. But now, if I work more than that, I start earning less. So, for example, if I worked for 18 hours there, I'd only earn $950. But on the green line, if I worked for 18 hours, I'd earn $970. So you can see that this point here, this point of intersection, is a really important point. If I work for less than 14 hours, which is the X value here for our point, if I work less than 14 hours, then the best pay rate for me is the purple one. That will give me more money. But if I work for more than 14 hours, then the green pay rate is actually the better way to go for me. And so you need to know how to take an equation like this, which might represent a pay rate, and plot a table of values on a graph, and then work out how much you would earn if you worked so many hours. So finally, let's just do that calculation. So for example, if I wanted to work out how much money I would earn if I worked for, say, 4 hours. So 4 hours of work, how much will I earn in each of these pay scales? Well, this one, I'm just plugging in X equals 4 because X is the number of hours worked. So for this one, it will be, the amount of money earned will be Y equals 40 times 4, so it's 4 hours, plus 250. So that will equal, 40 times 4 is 160, plus 250, and that will equal 350, that's $410. So $410 if I work for 4 hours with this pay rate. Over here, if I work for 4 hours, it'll be Y equals 35 times 4 plus 320. So 35 times 4 is 140, and plus 320. So 320, 420, that will give me $460. So clearly, working 4 hours, this is the better pay to go with, and the difference between the two, this is 460, this is 410, so the difference is $50. Okay, well, I hope this has been of some help, go through it again if you wish. Complete the problems that I've suggested here, and you should be absolutely good to go for the test on Friday. Okay, good luck. Thank you.